right, good morning, everybody. So today's topic is this thing called inheritance. I'm just going to skip ahead 2 slides for a second. So way back, I guess in week 3 of the course, roughly, I told you about this thing called the object model. Right? So our object model has these 4 things in it. We've got this thing called abstraction, encapsulation, modularity, and now we have the 4th one. We have hierarchy. Right? And so we've been talking about interfaces a little bit. And interfaces are one mechanism that Java has for implementing hierarchy in an object-oriented programming language. The other one is inheritance, right? Which is the topic of today's lecture. Okay, so inheritance is a relationship between 2 classes where one class is derived from another class. Right? So the idea of inheritance is simple but powerful. Right? When you want to create a new class, and there's already a class that includes some code that you want, you can derive your new class from the existing class. In doing this, you can reuse the fields and methods of the existing class without having to write and debug them yourself. Right? And so one view of inheritance is that it's a mechanism for code reuse. Right? There's a class somewhere that does something almost what you want it to do. And then you can take that class, you can extend it, and adapt it so that it does what you, exactly what it is you want it to do. Right? So in Java, inheritance is baked into the language. Right? So at the top of the Java hierarchy is this class called object. Right? Which, so you know that there's this class called object. You don't know that classes in Java are organized this way. Right? So at the top of this hierarchy is object, and then you might have a class here, for example, like string. Right? And you might have another one here like big D double, and another one here called big I integer, and so on and so forth. Right? Over here, sorry, you won't have big I integer over here, or double. You'll have number over here. So big N number is one of the classes in Java, in the Java standard library. Right? Under number, you might have a class integer, double, what else? Character, Boolean, et cetera, et cetera, et cetera. Right? And you can see here, the depth of the hierarchy is arbitrary. Right? So you can keep on extending classes for as long as you want, although generally that doesn't happen. All right, so we need to learn a little bit about the jargon that's used to talk about inheritance. Right, so inheritance isn't a Java concept. It's an object-oriented programming concept. So we have something called a subclass or a derived class. In Java, you often see extended class, and you'll often see child class. Child and derived and subclass are common when talking about object-oriented programming languages. Right? So a child class or a subclass is a class that's derived from another class. Right? So here we've got some class X or object. Right? And here we've got some class Y, that's a subclass of X. Right? String is a subclass of object. Right? So every class that's not object in Java is a subclass of object. Right? To draw the UML class diagram showing the relationship between these 2 classes, you take the subclass and you draw an arrow pointing to the superclass or the parent class. Right? That arrow, it has a very specific form, so it has this open triangle. Surprisingly, the different arrows in UML mean different things. So when you're drawing an inheritance UML class diagram that shows inheritance, it's important to remember to use the open triangle. The superclass is often called superclass or base class or parent class. That's the class from which the subclass is derived. And so you'll often see that you'll often see in object-oriented programming, in object-oriented literature, you'll see something like parent and child. Right? So object would be the parent class, string would be the child class. So in Java, everything is derived from object, but it's not necessarily directly derived from object. Right? So here's big O object. Right? There might be a child class of object called X. X might have a child class called Z, and Z might have a child class called A. Right? But A is still derived from big O object. Right? A is also derived from X, and A is also derived from Z. Right? And so the classes above A, these are called its ancestor classes. Right? So object is the ancestor class of all classes in Java. Right? Anything below object would be called its descendant classes. Right? So X is descended from object, Z is descended from object, A is descended from object. Okay, so why are we using inheritance? So when you have a class and you extend it, or you make a child class of it, right? The child or subclass inherits all of the non-private members from its superclass, right? So everything that's not private in the superclass, everything that's not private or package private gets inherited, right? So all the fields and all of the methods that are not marked private, right, get inherited by the child class. Right? Constructors are never inherited in Java, right? So if X defines a constructor here, right, Z does not inherit X's constructor, right? And A doesn't inherit Z's constructor either. All right, so if you have an existing class that provides some of the functionality that you want, you can derive a new class from the existing class. If you can arrange to do so, this often saves you a lot of work, right? A new class has direct access, so your subclass has direct access to the public and protected fields and methods without having to redeclare or re-implement them, right? So anything that's marked public in object, right, or protected, right, A has access to, right? And so that's why you can just call equals or toString or hash code on any object in Java. Right? Because the class object defines those methods, defines them as public actually. And that means every object has those methods. Right? Furthermore, the classes below object don't have to redefine those methods if they don't want to. Now a new class or the child class is allowed to introduce new fields and methods. Right? So it can add extra functionality and extra information, right, by adding extra methods and by adding extra fields, right? And finally, we've seen this already, right? Child classes are allowed to redefine or override, that's the term used in Java, right? Override methods that it inherits from its superclasses or its ancestor classes, right? And that's why we can change the way equals, toString, and hash code behave in the classes that we've been creating so far, right? Object says they exist. When we create a new class, you're actually using inheritance in Java because you're inheriting from object. So you can change the definition of any of the methods that you inherit. Okay, so what is inheritance supposed to be used for? So there's what inheritance is often incorrectly used for, right? So it's often incorrectly used for just for pure code reuse, right? You've got some class that does something that you want it to do. I'm just going to extend it and pretend that everything's fine, right? That's not what you're supposed to do. So inheritance is meant to model the is-a relationship between classes, right? So is-a. So in Java, everything is an object, right? String is an object. Array list is an object, right? And what that means is, so is-a really means your subclasses are substitutable for any of the ancestor classes, right? And so what does that mean? As an example, string is supposed to be a string object is supposed to be substitute for a big O object. What does that mean? It means that a string object can do anything that a big O object can do, right? It actually means something more than that, right? What it really means is anything that big object says it can do, right? So if we look at its methods and you look at the contracts for its methods, right? A string object is also supposed to be able to do those things and respect the contracts of big O object, right? So in Java, the class big O object is unique, right? It's the only class that has no superclass, right? So in Java, every class has a superclass except big O object, right? And so object in Java is the very top of the inheritance hierarchy, right? It's the class from which all other classes are descended from. If you create a new class and you don't say anything about inheritance, right, which we haven't done yet, right? We just say public class blah and away we go, right? Then the superclass for your new class is assumed to be big O object, right? So when we make our point2 class, its superclass is big O object even though we don't say so. In Java, a superclass is allowed to have many subclasses, right? Arbitrary number. So if X is our superclass, I can have Y, Z, and W, right? Those are all the subclasses of X, right? However, in Java, it's also the case that a subclass, so Y, Z, and W, they're only allowed to have one direct superclass, right? So Y can inherit from X, right? But it can't inherit directly from anything else, right? And this is called single inheritance, right? So child classes inherit from exactly one parent in Java. Some other object-oriented programming languages allow what's called multiple inheritance. So a class is allowed to inherit from more than one class, right? So this is not Java, right? So this would be a language like, for example, C++. Here we've got a subclass Z, right? Z is allowed to inherit from more than one superclass. So here Z inherits from Y and W, right? Now here Y and W, they both inherit from X, right? One of the reasons Java decided not to, or the designers of the Java language decided not to allow multiple inheritance is to avoid problems like this, right? So believe it or not, this actually has a name. It's called the deadly diamond of death, right? If you Google that term, you will in fact find a Wikipedia page that describes exactly this problem, right? So the problem is as follows, right? So I've got this superclass X. It's got some public method or protected method called F, right? Now, you know in inheritance, the subclasses inherit all of the public and protected stuff, right? So that means Y inherits a version of F from X, right? And W inherits a version of F from X, right? Now, Y and W are allowed to change how F behaves, right? So they can override the behavior of F, right? So they can change how the definition of F. And now you have a problem when you get to Z, right? Because Z inherits Y's version of F, and it inherits W's version of F. If both of these versions are different, the question is which one does Z inherit, right? And so that's the problem that you run into if you allow multiple inheritance, right? And the various languages have various ways of trying to deal with this problem, right? Okay, so from a Java point of view, is or is substitutable for means, right, you can use a derived class object anywhere you need an ancestor class object, right? So for example, suppose I have a method, right, and it takes in a parameter whose type is object, right, big O object, right? This is just like equals, right? Equals takes in a big O object, right? So here we have some class, right? It's got some method, right? Some method takes in a big O object, right? So what can you use to call this method, right? Do I need a big O object, or can I use something else, right? Well, this says that inheritance means is substitutable for, right? I can take a derived type object and substitute it for its parent, right? So that means I can take anything that inherits from object and pass it into this method. Right? So for example, I can take a string, right, and use that object to call some method, and pass that object to the method some method, right? That works just fine because string is an object, right? Is or is substitutable for, right? Is substitutable for, it takes too long to write. That's why most people write is a, right? Now what about hash set? So hash set's definitely not a string, right? But it is an object. So we can pass hash set, this object T, to this method and everything works just fine. Right. Similarly, we have this class point2, right? Point2 is not a hash set or a string, but it is a big O object, so I can pass it to that method right there, right? And everything will work just fine. Right? Now you might ask, what exactly is going to happen in this method, right? And so when you look at the method, it says it takes in a big O object, right? So inside the method, the only things that you're going to be able to do with obj is call some method belonging to big O object. Right, so you can call toString or equals or hash code or something like that. Right? In equals, that's why in equals we have to go through all of this work to test whether or not the object is actually an instance of the class that I want to compare against. Right? So that's why we need the instance of or get class, and then we need the cast. Right? It's because the method takes in a big O object, and we actually need it to be something else. Okay. Now, one of the things you have to remember is that this notion of inheritance is not a real-world concept, right? So is-a has nothing to do, or is substitutable for, has nothing to do with the real world, right? It's purely a programming construct, right? So this is important, right? Purely a programming construct, right? And it has everything to do with how the programmer has decided to model their inheritance hierarchy, right? So what it really means is the programmer creates a superclass, right? They decide on what the contracts of the superclass methods are, right? And it's those contracts that define what you can safely do when you inherit from the superclass, right? So there's a couple of classic examples that describe what you should not do when using inheritance. Right? So one of them is is a circle. So is an ellipse a circle, or is a circle an ellipse? Right? So in other words, if I create a hierarchy of classes to represent some shapes, right? And I start out by implementing ellipse, right? Can I safely reuse the code from ellipse to make a class called circle? Right? And so that's the question. The answer is maybe yes, maybe no. It depends, right? Now, mathematically, hopefully you know this by now, right? Mathematically, a circle is a kind of ellipse, right? So an ellipse, so a circle is just an ellipse where the semi-major and semi-minor axes have the same length, right? So that's true, right? So that's the real-world definition of ellipse and circle. So if you were to believe that your program reflects the real world, this would be fine. But you have to remember inheritance is a programming construct, right? So if the ellipse class can do something that circle cannot, right? So ellipse has some method that does something that doesn't make sense for a circle, right? Then circle is not an ellipse for the purposes of inheritance, right? So in other words, you should not do this, right? If ellipse can do something that a circle cannot, right? So remember what it means for inheritance, right? Inheritance means is substitutable for, right? So can I substitute a circle for an ellipse? Right? So if circle cannot do something that an ellipse can do, right? Then you can't safely substitute a circle instance for an ellipse instance. Right? So for example, this is an ellipse. Right? So in ellipse, we got this method called setSize. Right? It changes the size of the ellipse. Right? So every ellipse has a width and a height. Right? And it's independent, right? Ellipses have independent widths and heights, right? So presumably our ellipse class has a field called width and it has a field called height, right? And so it just sets the width to width and the height to height, right? Should do some validation here, but that just gets in the way for our purposes right now. Right? Okay, so what does it say? So the contract for ellipse says, changes the width and height of the ellipse to the specified positive width and positive height, right? So if you have an ellipse and you call setSize with 1 and 2, its width becomes 1 and its height becomes 2. Right? That's what the contract says. All right, so what happens if you do this with a circle? Well, that doesn't make sense, right? So if I do this with a circle, there's no guarantee that the resulting shape is still a circle, right? If you change the width and height of a circle independently, it's not a circle anymore, which is a problem, right? So circle can't do everything that ellipse can do in this example, right? Which means you cannot safely subclass ellipse to create a circle. Now, you might wonder why you can't do that, right? So why can't I do this if circle can't do everything that ellipse can do, right? So the answer is, it's because someone can come along and write a program or a method or whatever, right? They can write a program that involves using an ellipse, right? So they write some method that takes in an ellipse object. In that method, they call setSize, right? Assuming that the size of the ellipse is going to change to have that width and that height, right? So for example, they might be trying to fit that ellipse into another shape, right? They might be trying to fit it into a square or a circle, right? So they compute, a square or a rectangle of some sort, right? So they compute the width and height of the square or rectangle, and then they change the height and width of the ellipse so that it matches. Right? And then they draw it or do something with it, right? Or do some other calculation with it, right? Now, when you pass it a circle, right, depending on how you implement setSize for circle, right, suddenly that doesn't work anymore, right? And it depends on how the person, how whoever implemented circle implements setSize, Right? So the idea in all of this is that you're supposed to be able to write a program using the contracts of the superclass. Right? And then it doesn't matter what subclass object gets passed into your program, right, or to your method or whatever. Right? Everything is still supposed to work. Right? Okay, so that's fine. Right? So what happens if you make an ellipse class and then you subclass it with circle, but there is no set size method? Right? So it might be okay to do this. Right? As long as a circle can do everything an ellipse can do, right, then circle is allowed to be derived from ellipse. Right? As soon as circle can't do something that ellipse can do, then circle can't be safely derived from ellipse. Right? All right, anybody have any questions so far? Good? All right, so let's do exactly what I told you not to do. Right? So this is a naive inheritance example. Right, so you've all seen the stack. You're probably sick of it by now, right? But there is a way to implement a stack using inheritance, right? So remember when our first implementation of a stack, we used a list inside of it, right? So our stack was a composition of a list, right? And the reason we did that is because a stack looks a lot like a list, right? When you push an element onto the stack, it's like adding an element to the end of a list. Right? Popping an element from the stack is like removing the last element from the list. Right? So it kind of looks like that a stack is just a list. Right? And so if you decide to implement your stack this way, right? So I make a stack class, I inherit from list, right? Then you almost don't have to do anything to actually implement the stack. Right? So let's make a stack of integer using inheritance. Right? So I'm going to inherit from the ArrayList class. Right? So the way you do this is you make your class, right? So public class, some name, bad stack, because this is a bad example, right? And then you write extends. So extends is a keyword, right? And then you write the name of the class that you want to extend, right? So this is the parent class or superclass. That's the child class. Right? That's it. You've now extended ArrayList. Right? Now I need to add a push and pop method. So how do I push an element onto a stack? Well, I add an element to the end of the list, right? But bad stack, right, is a list, right? That's what extends mean, right? It really is a list. So that means bad stack has an add method, right? Because list has an add method. What does add do? It adds the element to the end of the list. So to implement push, I just write this add value, and that's it, you're done. Right? How do I remove an element from the end of the list? Well, list has got a remove method. Right? That means bad stack has a remove method. So I just call remove and remove the last element from the list. And that's it, you're done. Right? Look, there's no fields. Right? No constructors. Right? There's nothing, right? There's just two methods. And you have a fully functioning stack. Right? So for example, right, you write a little main method. I can make a bad stack. I can call push 0, 1, and 2. And you will, in fact, get a stack that has 0, 1, and 2 on it. Right? 2 is the top, 0 is the bottom. You can even print the stack. Look, I didn't override toString here, right? But I can still print the stack, and I get 0, 1, 2. Right? Why can I print the stack? Because I inherited toString from ArrayList. Right? So I can print the stack, and print line automatically calls t toString. I get the list version of toString, and I get 0, 1, 2 here. Right? I can pop the stack, right? So I can pop it 3 times. Every time the last element comes out, right? So 2, 1, 0 comes out. And everything looks great. I've got a stack, right? You might say, well, that was, so look, number one, it's super easy, right? Literally 1, 2, 3, 4, 5, 6, 7 lines of code if you count the import statement, right? But why should you not do this, right? The reason you shouldn't do this is because anything a list can do, you can also do with a stack, right? Because it inherits all the public stuff from ArrayList, right? So what does that mean? I can now go into the middle of the stack, right, and get an element from the middle of the stack, right? But you're not supposed to be able to do that with a stack, right? You're only supposed to be able to access the top element of the stack, right? I can go into the stack and set the middle element because list has a set method, right? I'm not supposed to be able to do that with a stack. I'm only supposed to be able to remove and add to the top of the stack, right? But now you can remove any element from the stack. You can even iterate over all the elements of the stack, right? So I can write a for each loop now over this stack and print out all the, or and do something with each element in the stack. And those are all things you're not supposed to be able to do with the stack, right? So for example, make a stack, push some elements on it, and now I can get the second element in the stack, right? So I can get the 200 from this stack, right? Even though I'm only supposed to be able to access the 300, right? I can go in and change the second element to minus 1,000, right? And that works. So using an inheritance in this example is an example of incorrect usage of inheritance. It's not the worst use of inheritance, but it's incorrect, right? So inheritance should only be used when an is-a relationship actually exists, right? So stack is not a list, right? It's not. Therefore, you should not use inheritance to implement a stack, right? If you do, the consequence is that people can use your stack as though it were a list, which, as I said, really isn't the end of the world, but it's not correctly representing what a stack is supposed to be able to do, right? Now, you might think all of this is academic or difficult, perhaps, but notice right here, right? Even experts sometimes get this wrong. So the people who implemented the Java standard library screwed this up, right? So if you go and look in the Java standard library, well, why don't we do that? Java 8, whatever stack. You'll see that there's a stack class, right? So there really is a stack class. It's in Java util, right? So in the same place where list and set and map all live, right? And notice what it does. Oh, so by the way, this here is showing you the inheritance diagram, right? So stack inherits, oh, don't go there, please. Oh, it went, sorry. Stack inherits from this class called vector, right? What's a vector in Java? So a vector in Java is, oh, it's a list, right? So the people who implemented the language actually created a stack just by extending this class called vector. Vector is the old ArrayList class. So they actually did this. They extended a class that's basically a list. And if you use the Java stack, the standard library version of stack, you can do things like get and set elements in the middle of the stack. Right. Okay. So if you're not supposed to use inheritance, what's the correct way to do it? You just use composition, right? So instead of stack is a list, right, which is what would happen if you're using inheritance, right? You use composition, and that becomes stack has a list, right? And now everything's fine, right? So our existing stack class that's implemented using a list inside of it, right? You can't do things like get or set an element in the middle of the list, right? You can only push and pop elements. Okay, so let's look at another example of inheritance, this time for something that's more closely approximating a better use of it. It's actually hard to teach inheritance to new programmers because all of the easy examples are really, really bad, right? They're all examples of things you should never do or would never be done in practice. This one is sort of something you might consider doing in practice, right? It's the simplest example that I can come up with. So remember our counter class, right? So our counter starts counting from 0, it goes up, it hits integer max value, and then it comes back around to 0, right? And it works just fine. Now the question is, you know, you're looking at this class, you're looking at some classes that you want to use, you need a counter of some kind, but you don't want it to wrap around when it hits integer max value, right? You want something else to happen. So can I take this counter class, extend it, and change the way that change what happens when it hits integer max value? Right. So remember our class, right? It's just got a private field called value, right? The advanced method checks is the value equal to integer max value, and if it is, if it's not, it adds 1 to it, right? Otherwise, it wraps it around to 0, right? So the question is can I change advance so that something else happens? So I can extend counter. There's no problem with doing that, right? I can override advance because advance is public, right? But that doesn't solve our problem quite yet, right? The reason doesn't solve our problem is because of this, right? The field value is private. And why is that a problem? It's because a subclass doesn't have access to the private fields of the superclass. Right? And there's no other way, right? And counter doesn't give you any other way to change the value. Right? The way counter changes the value is it sets this dot value. Right? So there is no hidden method, protected or private, that can update the value of the counter. Right? So that doesn't solve our problem, right? Because any class that extends counter is going to want to change the value in a different way, right? So it needs access to this dot value. And so this turns out to be a common problem when you try to extend a class that was never intended to be used for inheritance. Right? So our implementation of counter was never intended for inheritance because we didn't know anything about inheritance when we first implemented it. Right? So we're going to have to do some surgery on our counter class. Right? So if I want to extend counter in a meaningful way, I'm going to have to make that field accessible to subclasses. Or I have to add a method that lets subclasses change the value. Right? Either way. Right? So I'm going to change the access type on the field and make it protected instead. Right? So the protected access modifier allows subclasses to access a field or a method by name in the superclass. Right? So protected means subclasses are also allowed to access these features. Right? So I can just go in and change value to protected. Right? Anything that's not a subclass, right, like point2, still can't see the value field. Right? But the subclasses can see the value field. Right? Nothing else changes here. Oh, I guess we added another constructor here. That's fine. Okay, now if I'm going to adapt this counter class to be used for inheritance, right, then what I have to do is I have to go in and probably modify the contract for advanced to indicate that subclasses might change the way the method works. Right? So I have to go into advanced, right? So advanced, the contract says it increments the value of the counter by 1. If the method is called when the current value of the counter is equal to integer max value, then the value of this counter is set to 0. Right? That's what the original contract read as. Right? And so that means any class that overrides advance has to also wrap the value back to 0 if they override the method. Right? And so you have to change your contract to say that something like subclasses can change the way this method behaves. Right? Otherwise, if you don't add that in, right, someone can write a bunch of code that uses the counter contract, right? And now when you pass in a different type of counter, their code breaks all of a sudden, right? Because their code assumes value is going to wrap around to 0. Right? As soon as you put in language like this, right, people aren't allowed to assume that the value is going to wrap around to 0. Right? They have to consider that something else might happen. Notice that there's no way in the language to actually enforce this. Right? So there's no way in code that you can enforce, if you use inheritance, someone can still do something funny with the value, right? All right, so why do we modify the contract for advanced? Because subclasses are supposed to be substitutable for the subclass. Right? If you don't modify the contract, there's no way for subclasses to change how advanced works. Right? Okay, now you can change counter. Now you can extend counter to implement different strategies for when the counter hits integer max value. Right? So for example, I can make a counter that stops counting when it hits integer max value. Right? So it counts up to integer max value, and then if you advance it, it just keeps on giving you back integer max value. Right? So we'll make a new class called stopping counter, because this counter stops when it hits integer max value. Right? We're going to extend counter. Right? Now remember what happens when you extend counter, right? You inherit everything that's public and protected from the superclass. Right? So we inherit a field called value, and we inherit all of the public methods. Right? And that means you do not put your own value field here. Right? The value of the counter is always stored in this example in the superclass. Right? You do not add a new field called value here. Right? If you do, you're circumventing the whole point of inheritance. Right? The point of inheritance is you're supposed to reuse the code that you have from the existing class. Right? Question? You can add as many other fields as you want. You can even add a field called value. So the language lets you put in a new field called value, and now you've got a counter class, you have a counter object that has 2 fields called value. the way you access them is different. So whatever you do, right, if you add a new field to your class, you should really avoid naming it the same as an existing field. Right? It does, but the language does allow you to put in a new field that has the same name as an existing field. That was probably an oversight. Okay, so there's no fields, right? The current value of the stopping counter is stored in a field that belongs to the superclass, right? And there's no purpose, there's no reason for a stopping counter to add a new field to store the current value, right? There's already a field that can do so, right? Why double the amount of memory that you need to store just a single integer value, right? Subclass is allowed to add new fields, right? Now, so here's the interesting part here, right? So the subclass can see the public and protected fields of the superclass. The opposite is not true, right? The superclass can't see any fields in the subclass, right? So inheritance is a one-way relationship, right? The superclass knows nothing about its subclasses, right? And that means it can't access the fields in the subclasses either. Right? Okay, so I should implement a constructor, right? Because that's how we make new objects, right? So I want to implement stopping counter, the stopping counter constructor. I want to set this value to 0, right? And so one way to do this is to write this value equals 0 because we have access to the field called value. Right? However, there's a better way to do this. The purpose of a constructor is to initialize the value of the fields of the object, right? That's what every constructor does, right? So how can a constructor set the value of a field that belongs to the superclass, right? So remember, value does belong to the superclass, right? So if there's a field in the superclass that's private, right, that field still needs to be initialized somehow, right? But the subclass doesn't have access to that field, right, because it's private, right? Subclass does not have access to the private fields of the superclass. So how can the subclass initialize any private fields that belong to the superclass, right? So the answer is how do you initialize the fields of any class, right? You call a constructor. So subclasses are allowed to call the superclass constructor, right? The way you do it is with the keyword super, right? So super round bracket calls the superclass calls the no argument superclass constructor, right? That's why you have round bracket and nothing in between, right? So that calls the counter constructor. The counter no argument constructor sets the value to 0. Right? And so that's how you, that's one way to call, this is one way to call the superclass constructor. All right. Now there's a bunch of rules surrounding, that are related to this. Right? So as soon as you create a subclass, you have to be aware of the rules regarding what your constructors look like. Okay, so in a subclass, the first line in the body of every constructor must be the call to another constructor. Right? So that's rule number 1. So as soon as you write your stopping counter constructor, the first line is supposed to be the call to another constructor of some kind. Right? Now, if it's not, right, then Java inserts a call to the superclass default or no argument constructor for you. Right? So if you don't put a call to the superclass constructor or another stopping counter constructor, the compiler automatically inserts that for you. Now, what happens if the superclass default constructor does not exist or is private? Right? Then when the compiler inserts the call to the no argument constructor, it fails, right? And then you get a compilation error. So if you don't put a call to another constructor on the first line of your constructor, subclass constructor, right, it has to be the case that the class you derive from must have a public or protected no argument constructor. Okay, so the first line must be a call to another constructor, and the only place you can call another constructor is on the first line. Right? So in other words, you cannot write super something to call a superclass constructor on the second or third or fourth line of your method, constructor, sorry. Right? You can only do this on the first line of a body of a constructor. Finally, a superclass constructor must be called somewhere in the process of initializing your derived class object. Right? Why does this have to happen? Because the superclass might have private stuff in it that has to be initialized. Right? The only way to initialize that stuff is by calling the superclass constructor. Right? So when you make your subclass constructor, at some point, you've got to call the superclass constructor. Right? So you're allowed to call any superclass constructor, right? It doesn't have to be the no argument constructor. So you can call any one of them. Okay, you might wonder why these rules exist. I don't know if I'll get there today, but I will explain exactly why these rules exist. Okay, so I can add a second constructor that initializes the counter to a specified non-negative value. Right? So I can create a stopping counter constructor that sets it to that value. Right? So what goes here? Well, lots of things can go here. Right? I can call the superclass no argument constructor, or I can call the superclass constructor that sets the value to this value. Right? Or I can just write this value equals value. They're all legal and potentially correct. Right? But you can actually do a fourth thing. Right? So you can actually use constructor chaining in this example. Right? So the first line of a constructor should be a call to another constructor. You don't have to call the superclass constructor, though. Right? All that's required is that eventually, somewhere along the way, the superclass constructor is called. So for example, right, here's the no argument constructor. Right? Before we use super round bracket, right? This time I'm going to use constructor chaining. So I'm going to write this 0. So that calls this constructor down here. Right? This is fine. This is the first line of my constructor. It's a call to another constructor. So we go down to here. Right? This constructor calls the superclass constructor. Right? Which is good. So that first line of this constructor, call to another constructor. Right? When this constructor calls this constructor, the superclass constructor gets called. So this is fine too, because the first line of my constructor is a constructor call, and the superclass constructor eventually gets called. Right? So this is all fine. Right? This is you have to remember, this is the simplest example that I could come up with. Right? In this example, it doesn't necessarily make sense that you would do it this way, right? Because there's only one field in the class. You could just initialize the field yourself, right? But this illustrates the technique of calling the superclass constructor and reminds you what constructor chaining is. Right? Do I have time to do this? Yes. Okay. So why are all these seemingly complicated and convoluted rules needed, right? And so the answer is you have to know what a subclass actually is, right? So a subclass looks like a new class. It has the same contracts of its superclass, right? And it might have some additional methods and fields, right? But inheritance does more than just copy the contracts of the superclass, right? And copy over all of the public and protected stuff, right? What actually happens is, right, your subclass object actually contains a subobject of the parent class type, right? So inside every stopping counter is a counter object, right? So inside every stopping counter is a counter object, right? Inside every string object is a big O object, right? Inside every point2 object is a big O object. That superclass subobject needs to be constructed, right? It's an object, so it has to be initialized. Right? How do you initialize any object in Java? Well, you call a constructor. Right? So, why is the constructor call to the superclass needed? Right? Because stopping counter is a counter. Right? The counterpart of stopping counter needs to be constructed. Right? So here's a picture of what's going on. Here's a bad picture of what's going on. Sorry. I remember this mistake. This was a copy and paste error that I never fixed. Okay, so I'm going to make a new stopping counter, right? And it's going to start at counting at 1, right? So what happens, right? So new allocates memory for a stopping counter object, right? So that's what new does, right? New then calls the stopping counter constructor, right? So the stopping counter constructor starts running, right? What's on the first line of the stopping counter constructor? Right? The first line is a call to the superclass constructor, right? So it makes the counterpart of the stopping counter object, right? On the first line. Right? Now what happens? Well, I just called the counter constructor, so the counter constructor is now running, right? What does the counter constructor do? Right? So if you remember back what the counter constructor does, it says this dot value equals 1, right? But the counter is actually a subclass of big O object, right? I never called the big O object constructor on the first line of the counter constructor. So the compiler silently inserts a call to the big O object constructor, right? To make the object part of counter, right? So now what happens? Well, the object constructor is running, right? So it does whatever it needs to do. I don't know what it does, right? But eventually it finishes. Right? And so now, the counter constructor can actually start doing whatever work it needs to do. Right? So the counter constructor sets value to 1. Right? And now it's done. Right? Okay, so now what happens? Well, the stopping counter constructor called the counter constructor, and now the stopping counter constructor can continue to run. Right? So it doesn't do anything else. All it does is call the counter constructor. Right? So it's done now. Right? And now your stopping counter object is complete. Right? But notice the order in which objects are completed. Right? So stopping counter object is created, and we start to initialize it. Right? That causes the counter object inside of it to be created, and we start to initialize it. Right? That causes the object part of the counter to be constructed, and we start to initialize it, right? And then we're done, right? So we finish building the object part, right? So the way this works in Java is the classes that are higher up in the chain, in the inheritance hierarchy, they get built first, right? So object gets complete, the object, big O object is constructed and completed first, right? Then the counter object finishes construction. Right? So now the counterpart of the stopping counter object is done. Right? And it's not till you get to the end of the stopping counter constructor that the stopping counter object gets built. Right? So the sub-objects inside of an object, they get built from the top down. Right? Or from the inside out. Right? Object gets built, object gets completed first, then counter gets completed second, and then finally stopping counter gets completed third. Right? That turns out to be important, but I don't know if we're going to. I don't know if we're going to get. I don't know if we're going to talk about the what happens if you mess things up. All right, we're almost done. I can finally finish implementing advance. Right? So advance stops counting if it hits integer max value. Right? So if the value is not equal to integer max value, add 1. Otherwise, do nothing, and that's it, you're done. Right? So the actual implementation is easy. Right? You put in some constructors, but they're all very short. Oh, wait, here, right? So you put in your constructors, right? If you're lucky, you just have to call another constructor or a superclass constructor. If you add some extra fields, you'll have to initialize those fields too, right? So if we added fields to stopping counter here, you would initialize them on this line here or on this line here, right? And then you override whatever methods you need to override, right? And so we override advance, and we're done, right? You've now got a stopping counter. You've now got a counter that stops counting when you hit integer max value. All right, so we're basically out of time. Anybody have any questions? I've got like a minute. No? All right, so next class, we'll look at another example of extending counter, and then we'll move on with some other examples.